Hi, we're going to go over how to find horizontal asymptotes when working with rational functions. So remember that rational functions look like fractions. They have x values in the denominator, and they have vertical asymptotes, which we went over on the previous video. Today we're going to look at how to find these horizontal asymptotes. Now these asymptotes come down to the degree of the numerator compared with the degree of the denominator. So if the numerator has a lower degree than the denominator, then we have a horizontal asymptote at y equals 0, which is just the x-axis. So one way to remember that is if we have small over big, then we have the horizontal asymptote y equals 0. Another asymptote happens when we have the same degree over the same degree. So if the numerator and the denominator have the same degree, then the asymptote is found by taking the leading coefficient over the leading coefficient. And that's what they mean down there by A over B. That sub in is just differentiated from a different coefficient, but you're taking the leading coefficient of the numerator over the leading coefficient of the denominator. Now, the third case is if you have large over small, and in that case, you don't get a horizontal asymptote, you get an oblique or a slanted asymptote. Now, what that is a slanted line. It's not a horizontal line, it's not a vertical line, it's a slanted line. We are not going to cover those in this class. So all you have to know is when you have a larger degree on the top than you do on the bottom, and it has to be a larger degree of exactly one more, then you get this slant or oblique asymptote. So just to summarize, to find the degree of the horizontal asymptote, we need to compare the degree of the numerator to the degree of the denominator. The three cases are the degree of the top is less than the degree of the bottom, so we have a small over a large. In that case, our horizontal asymptote is y equals 0. A second case is that the degree of the top is equal to the degree of the bottom. In this case, we have the same degree over the same degree. So this is where our book calls this y equals a over b. And what they mean by that is the leading coefficient of the numerator divided by the leading coefficient of the denominator. And the last case is if the degree of the top is greater than the degree of the bottom, in other words, large over small, then we don't have a horizontal asymptote. We have an oblique or a slant asymptote. And again, we're not covering that in this class. So let's look at this example here. We're to find the horizontal asymptotes if there are any. So we look at the degree of the numerator and the degree of the denominator. Well, the degree of the numerator is 1, because that's x to the first power. The degree of the denominator is 2, and I can figure that out in two ways. First of all, I have two factors, so degree 2. That comes from the idea that if I multiply those together, the biggest exponent would be 2. So since I have a small over a large, the horizontal asymptote is just the x-axis, y equals 0. And that's what the horizontal asymptote would look like on our graph. How about this one here? F of x equals 2x plus 1 over x minus 3. So again, we look at the degree of the numerator and the degree of the denominator. They're both 1. So in this case, we have same over same. So we're using our leading coefficient over the leading coefficient. So we would have 2 over 1, because this coefficient here is 1, or just the line y equals 2, which is this horizontal line shown in this picture. Our third example has 2x squared plus 5x minus 1 over x minus 3. What's the degree of the numerator? What's the degree of the denominator? Well, in this case, the degree of the numerator is 2 and the degree of the denominator is 1. So that turns this into a situation where we have large over small. So we do not have a horizontal asymptote. It's an oblique asymptote, and I am not going to ask you to graph those. I just want you to be able to identify those functions that have oblique asymptotes. So as long as you can tell me that large over small means oblique asymptote, you are good.